We are going to start now the second chapter of class 12th mathematics, inverse trigonometric functions, and this is lecture 1. So first of all, we are going to discuss some results that we have already studied in our previous chapter related to invertible functions. So the first result we have studied that a 1 on 2 function is called an invertible function. The basic definition of invertible function we were having, that f is a function that is defined from x to y. We are saying if there exists a function g from y to x such that f o g is equal to g o f is equal to the identity function, then g is called inverse of f, and we write that g is equal to f of inverse. And we have seen that the inverse exists if the function f is both 1 and onto. So this is also an equivalent definition. We are saying that a 1 onto function is called an invertible function. So next thing we are talking about over here, it is the inverse of a function. So we are saying that f is a function defined from x to y and it is a 1 onto function. Then for each y in y there exists a unique element in x such that f of x is equal to y, and the inverse function f inverse, we are saying it is defined from y to x such that f inverse of y is equal to x. This implies and implied, this is implied and this implies that f of x is equal to y. The domain of f inverse is the range of f and the range of f inverse is the domain of f. These things we have already studied in our previous lecture. Next thing we have studied is one more important thing that will be useful in this chapter is that if suppose the graph of a function, say it is in this form, this is the function f, we are saying this is x axis, y axis, and if we want to draw the graph of the inverse function, then we are saying we have to draw the line over here. This is the line we are talking about, x is equal to y. The image of this function along this line, the image of this function along this line, this is the graph of the function f inverse. The image of the function along this line x is equal to y, that gives us the graph corresponding to the function f inverse. So in our previous chapter we have already seen that the trigonometric functions in general, they are not 1 onto, so they are not invertible. But if we restrict their domains, then we can make them 1 and onto, and hence we can find the inverse of these functions. So the example is given on our next slide. So if we are talking about the sine function, I am plotting the graph of sine function. It looks like this. So what we can see from this graph is that if I am drawing a line over here parallel to the x-axis, if I am drawing this line parallel to the x-axis, I can see that this line is intersecting at different points. So clearly this function is not 1 onto. So if I am talking about the sine function and I restrict the domain of this function, suppose I am talking about, I have restricted the domain of this function, this is the point minus pi by 2 and the value corresponding to it is minus 1, and at this point pi, the value of the function it is 1. So if I restrict the domain of the function from minus pi by 2 to pi by 2, the graph of this function in this region, it is in this form. This is corresponding to the point minus pi by 2, this is corresponding to the point pi by 2, this is x axis, this is y axis, this is the point 1 and this is the point minus 1. And if I am writing, this function is defined from this to minus 1 to 1 closed interval, then on this interval this function is, sine function is 1 and onto. For these sets this function is 1 and onto. Suppose in place of this minus pi by 2 to pi by 2, I am talking about the values over here. at this point this function will continue like this. I am talking about this region. Corresponding to this point is 3 pi by 2, and this point we have it is 5 pi by 2. I am saying if I restrict the domain to the interval 3 pi by 2 to 5 pi by 2 on this interval, and we are taking the codomain as -1 to 1. For these two sets also this function is 1 1 and on 2. So this thing is mentioned over here, that the sine function restricted to any of the intervals in this form, it is 1 1 and on 2. In case the range we are considering or the codomain we are taking, it is -1 to 1. And on these intervals we can define the inverse of sine. It is written in this form. We can define the sine inverse of x. Inverse function is defined on these intervals, and it is written in this form. And each of these are called the branches of sine inverse of x. This is called a branch of sine inverse of x. This is called a branch of sine inverse of x. And out of all these branches, if we are restricting to these values from minus pi by 2 to pi by 2, we are saying this is called the principal. This minus pi by 2 to pi by 2, this is called the principal value branch, and the values belonging to it, they are called the principal values. An important thing to mention over here, it is being mentioned over here, that we are talking about this notation, it is sine inverse x. We should not confuse it with this thing, that sine x inverse. If we are talking about this second case, it is basically, we are saying it is 1 over sine x, but this is the inverse function we are talking about. This is not the inverse function, this is reciprocal of the function sine x. This is not the inverse function. So we are saying that the inverse function sine inverse, it is defined from its domain is -1 to 1, which is the codomain of the function. Sine function we are saying, we are restricting it to minus pi by 2 to pi by 2, and the codomain we are writing it is -1 to 1. Now the codomain for this, it will become the domain of the inverse function, and the domain of this will become the codomain of this function. So we are saying we denote the sine inverse by this, and this is how the sine inverse is defined. So the domain of this function, it is from -1 to 1, and the range of this function, it is minus pi by 2 to pi by 2. Similarly, if we restrict the domain and the range or the codomain set of other trigonometric functions, we can obtain the corresponding inverse trigonometric functions and different branches corresponding to it. And on our next slides, we will discuss these functions in detail. So the first function now we are talking about, it is sine y is equal to x. We are saying if sine of y is equal to x, then y is equal to sine inverse of x under certain conditions, and those conditions we have already seen. We are saying that sine of y is equal to x, then y is equal to sine inverse of x, and this thing holds under certain condition, and that condition is, we are saying the value of sine y, it varies from -1 to 1. Now the sine y we are saying this is equal to, in place of sine y we are saying it is x. So this thing implies us that -1 is less than equal to x is less than equal to 1. This thing we have already seen from our graph also in the previous slide, but we are saying this is basically representing the domain of sine inverse of x. And when we are talking about the codomain set, the range of this function, then the range of this function we are saying it is, if we are talking about the principal values, then they are minus pi by 2 is less than equal to y is less than equal to pi by 2. This is the case when we are restricting to the principal values. So we are saying that for these domain and codomain, this function y is equal to sine inverse x is defined, it is meaningful, and the domain of this function, it is -1 to 1, and the range of this function, it is minus pi by 2 to pi by 2. We can restrict the values of the y in any of these intervals, but these are not the principal branches. This is the principal value branch, minus pi by 2 to pi by 2. It is the principal value branch. This thing is fixed, you cannot change it. This is universally accepted definition, you cannot change it. Next thing we have is we have to plot the graph of this function. So to plot the graph of this function, we are going to plot the graph of sin x in this region. We are saying the graph of sin x in this region, it is at 0 the value is 0, then these values they increase like this up to the point this is pi by 2, and in this region this graph is like this. This is corresponding to the point minus pi by 2. This is the graph of the function y is equal to sin of x. Now when we have to plot the graph of sine inverse function, we are drawing the line over here. We have drawn a line over here. This line we are saying it is x is equal to y, and if we take the image of this graph along this line, we obtain the graph of the inverse function. This is the image of this graph along this line x is equal to y. So we obtain the graph of the inverse function in this form. So this graph, it is shown over here. This is the graph of the inverse function. So this is for the principal branch. Similarly, we can plot the graph for any other branch. The next function we are talking about, it is the inverse function for the cos. So we are saying let cos of y is equal to x, then y is equal to cos inverse of x. We are talking about the inverse of function of cos. It is again, we are saying it is defined under certain condition, and those conditions we can calculate from this value. We are saying that minus 1 is less than equal to y is less than equal to not y, it is less than equal to cos y is less than equal to 1. So it means we are saying that the value of x we have over here, it is minus 1 is less than equal to x is less than equal to 1. So the domain of this function, we are saying it is from minus 1 to 1. We are talking about the domain of the function y is equal to cos inverse of x. The domain of this function is minus 1 to 1. Now if we look at the graph of the cos function, if we look at the graph of the cos function, its value is over here. It goes like this, it goes like this. At this point we are saying this point is 0. This point we are having it is minus pi, and this point we are saying this point is corresponding to pi. At 0 the value is 1, and corresponding to pi the value is minus 1. So if we restrict ourselves to this interval from 0 to pi, we are saying that this cos function, it is attaining the value from minus 1 to 1. So the principal branch in case of cos y, we are saying it is 0 to pi. This is the principal branch in case of cos inverse of y. So we are saying that the domain of this function, it is minus 1 to 1. That is the values this x can take, they can vary from minus 1 to 1, and the answers it will give for principal values, we are saying it is 0 to pi. This thing you should remember, that when we are talking about the sine function, the principal values they are from minus pi by 2 to pi by 2. When we are talking about the cos function, the principal values are from 0 to pi. So next thing we have to do is we have to plot the graph of this function. So to plot the graph of this function, we have seen over here, we are drawing the graph of cos x. We have already drawn it over here, so I will explain it over here to you. We are saying in this first figure, this is the graph of the function cos x in the interval 0 to pi. What we are saying is, if we want to plot the graph of the inverse function, what we have to do is, I am drawing this graph again over here. This is the graph of the function in this interval. This value we are saying in this form. Now we have to draw the line y is equal to x or x is equal to y we are saying, and we have to take the images of these points corresponding to this line, and we will obtain the graph in this form. Or the another thing we can do is, we are going to, this is the graph corresponding to y is equal to, this is the graph corresponding to y is equal to cos of x. We are saying we have rotated this graph by an angle of 90 degree. We are saying it is plus 90 degree, it means it is anti-clockwise we have rotated. So when we rotate it anti-clockwise at an angle of 90 degree, we obtain the graph in this form. And after that we have taken the reflection of this graph about the y axis. We have taken the reflection of this graph about the y axis, and the graph we obtain it is in this form. So you can opt any of these methods. You can take the image along the line x is equal to y to find the graph of the inverse function. Second procedure is rotate the graph by an angle of 90 degree, means anti-clockwise by an angle of 90 degree. Then take the reflection about the y axis. If this is the graph of y is equal to cos x, then this is the graph of y is equal to cos inverse of x, and this is the graph we have plotted over here. This is the graph of the function y is equal to cos inverse of x. This is the graph we are talking about. Next function we have, it is tan inverse of x. So for this function we are going to draw the graph of the function. We are talking about the graph of the function tan x. The graph of the function tan x, it is of this form. This is corresponding to the value minus pi by 2. This is corresponding to the value pi by 2. It is approaching to infinity towards this side. It is approaching towards minus infinity on this side. So if we are talking about the function y is equal to tan inverse x, so what are the possible values of x over here? We are talking about the function tan y is equal to x. So what are the possible values of x? X can take any value from minus infinity to plus infinity. We are saying x can take any value from minus infinity to plus infinity. And the values of y, we are saying these are restricted from the interval minus pi by 2 to pi by 2, and on both these sides, both the endpoints, this interval is open because the function is not defined at minus pi by 2 and pi by 2. So what we obtain from this is that the domain of this function, it is x belongs to R, that is x belongs to minus infinity to infinity, and the range of this function, when we are talking about the principal values, it is the open interval minus pi by 2 to pi by 2. This open interval is important over here, because when we are talking about the principal values or principal branch of sine inverse function, it was closed interval minus pi by 2 to pi by 2, but when we are talking about the tan inverse of x, the principal values we have, it is open interval minus pi by 2 to pi by 2. Next we have to plot the graph of this function. So the first thing we will have to do is we have to rotate it by an angle of 90 degree. If we rotate this graph by an angle of 90 degree, we obtain the graph in this form. Then next thing we have to do is we have rotated the axis by around these axes we have rotated by an angle of 90 degree, and after that we have to take the reflection about the y axis. Now if we take the reflection about the y axis, this graph will become this. So we are saying the values that we have over here, we are talking about these values. So when the value of y is pi by 2, this value is approaching towards infinity. When the value of y is minus pi by 2, this value is approaching towards minus infinity, and this graph is shown over here, that this is the graph for y is equal to tan inverse of x. and this is how we are obtaining this graph. That first of all we have rotated the axis by 90-degree angle, and then we have taken the reflection about the y axis. The next function we are talking about, it is cot of y. So corresponding to this function, we are saying if we have cot of y is equal to x, then y is equal to cot inverse of x, and this is defined under certain conditions. So if we plot the graph of this function, then its graph is of this form. So we are saying corresponding to 0, the values they are approaching to infinity, and corresponding to this value pi, its values they are approaching to minus infinity. So this is the point we are saying this is pi by 2 over here. At this point the value of the function, it is 0. So what we can see is, when we are talking about the function y is equal to cot inverse of x, this is corresponding to the function cot of y is equal to x. So what is the range of this function cot of y is equal to x? The range of this function is minus infinity to infinity. It means the domain of this function is minus infinity to infinity. If we are talking about the domain of this function, for this function to be 1 1 on 2, the domain should be restricted to 0 to pi open interval, because the function is not defined at 0, the function is not defined at pi. So we are saying that the range of this function, it is 0 to pi, and the domain of this function, it is x belongs to R. This interval 0 to pi, it is an open interval, and if we plot the graph of this function, we obtain the graph in this form. So you can rotate it by an angle of 90-degree, followed by the reflection along the y axis, and you will obtain this graph in this form. The next functions we have, it is the function secant y is equal to x, and corresponding to it the function we have, it is y is equal to secant inverse of x, and second we are saying y is equal to cosecant inverse of x. So the domain and the codomain of these functions we have over here, that this function, when we are talking about secant of y is equal to x, so what are the possible values of x? We are saying either x is greater than equal to 1 or x is less than equal to 1. If we plot the graph of this function, it is secant x we are talking about. So this is corresponding to the function cos y. This is the corresponding to the function cos of y. So if we plot this function, we are saying when the value over here, it is 1, the value is 1, it is approaching to 0. So we have something like this over here, then we have something like this over here, we have something like this over here, we have something like this over here, and something like this over here. So if we look at these graphs, the values there, when this value is becoming 0, this value is approaching to infinity. When this value is becoming 0, this value is approaching to infinity. So what we can see from this is, if we are restricting to the interval 0 to this value, it is pi by 2, and then this value we are saying over here, it is pi. So if we look at this portion of the graph over here, if we look at this portion of the graph over here, we are saying corresponding to pi by 2, on this side the value it is minus infinity, on this side the value it is infinity. Corresponding to this value pi, we have this answer we have, it is 1, and corresponding to this value 0, the answer we have, it is 1. So the value of x, they are always greater than equal to 1 or less than equal to minus of 1. It means that the function, the domain of this inverse function, it is all real numbers except for the numbers lying between minus 1 and 1. And the range of this function, it is 0 to pi. It can take any value from 0 to pi, but the problem is only at the point pi by 2, where the function is approaching toward infinity or minus infinity. So we are saying the range of this, or the range of this inverse function, we are saying it is 0 to pi except the point pi by 2. Similarly, when we are talking about the function cosecant y, we will have the domain of this function is all real numbers except the interval, the numbers between -1 and 1, and the codomain, the range of this function we are talking about, it is for the interval minus pi by 2 to pi by 2 except the point 0. So to look at this case over here, if we plot the graph of sin x, the graph of sin x is in this form, on this side it is in this form. This is the point we are saying it is pi by 2, and this is the point we are saying it is minus pi by 2. Now if we are plotting the graph of the function, we are talking about these are the graphs of the function cosecant of y. So if we are restricting to this interval from minus pi by 2 to pi by 2, we can see that at this point 0, this is approaching towards minus infinity and this is approaching towards infinity. Between all the points between minus pi by 2 to pi by 2, we have left the point we are not considering, it is this point 0 we are not considering. And if we are talking about the range of this function, we are saying it is varying from, in this case the function, it is varying from 1 to infinity, and in this case it is varying from minus 1 to minus infinity. So what we obtain from this is that the range of this function, it is minus pi by 2 to pi by 2 except the point 0, and the domain of this function, it is r minus the points lying between minus 1 and 1. And the graphs of these functions, these are shown over here. These can be obtained from the graph of secant y and cosecant y by rotating about rotating the axis by 90-degree angle, and then by taking the image or reflection along the y axis. So these are the graphs of these two functions, y is equal to secant inverse x and y is equal to cosecant inverse x. So the properties that we have studied till now, we have listed them in this table. So we are talking about over here the first function, we are saying it is y is equal to sin inverse x. Domain of this function is from minus 1 to 1 closed interval, and the principal branch or principal values, they are lying in the interval minus pi by 2 to pi by 2, and this interval is closed. Then when we are talking about the function cos inverse of y, its domain is minus 1 to 1, principal values they are from 0 to pi closed interval. Next we are talking about the function y is equal to tan inverse x. The domain of this function, it is r, and the range of this function or the principal values we are considering, it is open interval minus pi by 2 to pi by 2. Next we are talking about the functions, it is y is equal to cosecant inverse of x and y is equal to secant inverse of x. In both these cases the domain we have, it is r minus the open interval minus 1 to 1, and the range in this first case we have, it is minus pi by 2 to pi by 2 minus the point 0, and in this second case it is 0 to pi minus the point by removing the point or except the point pi by 2. So these intervals you can see from here also, you can compare these values from here also. And next last we have studied, it is y is equal to cot inverse of x. The domain of this function, it is r, and the range set or the principal values we are saying, it is from 0 to pi, and it is open interval 0 to pi. Now we have certain problem based upon these formulas or these definitions. So first is find the principal value of each of the following. First is sine inverse of 1 by square root of 2. So basically we want to solve the equation. Suppose we are saying that sine inverse of 1 by square root 2, this is equal to theta. So this thing implies us that sine of theta, that is equal to 1 by square root 2. We have to solve this equation and we have to calculate the values in the principal values we are talking about. So we know that how to solve this. The answer for this we obtain it is sine of pi by 4, that is equal to 1 by square root 2. So what we get from this is that theta is equal to pi by 4, which belongs to minus pi by 2 to pi by 2. First thing is that there can only be one value over here. There cannot be more than one value, because on the principal domain when we are talking about the function, it is both 1 1 and on 2. So we will have only one answer over here. You need not to check for any other. If you have calculated one answer, that will be sufficient. So your answer is over. You need not to check whether any other point lies in this interval or not. So this is the answer for our first part. Second is cos inverse of square root of 3 by 2. Let this is equal to theta. It means we are saying that we are interested in those values of theta for which cos theta is equal to root 3 by 2, and we are interested in those values of theta which lie between 0 and pi, which lie between 0 and pi. So we are saying the value, this cos theta will attain the value root 3 by 2 for the angle pi by 6, and this angle pi by 6, it lies between 0 and pi. So the principal value we obtain, the value of theta we obtain, it is pi by 6. So we are writing that cos inverse of square root 3 by 2, that is pi by 6, and this is basically the principal branch or principal value we are talking about. Next is the function. We are saying it is tan inverse of square root 3. So we are saying that tan inverse of square root 3 is equal to theta. So we are saying we are interested in those values of theta for which tan theta is equal to root 3, and theta should belong to the interval, open interval, minus pi by 2 to pi by 2. So we are interested in those values of theta over here. We know that the value of theta will be tan theta will be root 3 for the angle pi by 3. So we get that theta is equal to pi by 3, and it belongs to the interval minus pi by 2 to pi by 2. Now to remember these principal domains we are talking about, next we have to calculate the principal branch corresponding to the function. It is cosecant inverse 2. Suppose we are saying this is equal to theta. So we want to calculate that theta for which cosecant of theta is equal to 2, and this theta we are talking about, it should lie in the interval minus pi by 2 to pi by 2 minus 0, except for the point 0. So the value of theta we have, it is cosecant of pi by 6, that is equal to 2, and this pi by 6, it lies in this interval. So we are saying that the principal branch or principal value of cosecant inverse of 2 is pi by 6. Next is we have to calculate the principal values in each of these cases. The first function we have, it is sine inverse of minus 1 by 2, and suppose that this value is equal to theta. So we are saying it is sine of theta should be equal to minus 1 by 2. This is equal to minus of sine of pi by 6, and this is equal to sine of minus of pi by 6, and this minus pi by 6, it belongs to the interval minus pi by 2 to pi by 2. So we are saying that the principal value of sine inverse of minus 1 by 2 is minus pi by 6. Next is we have to calculate the value for sine inverse of minus square root 3 by 2. Suppose this value is equal to theta, and the value of theta, it should lie in this interval from minus pi by 2 to pi by 2. So what we get from this is that sine theta should be equal to minus root 3 by 2. This implies as sine theta that is equal to minus sine of pi by 3, that is equal to sine of minus pi by 3, and this minus pi by 3 it belongs to the interval minus pi by 2 to pi by 2. So we are saying that the principal value of sine inverse of square root minus square root 3 by 2 is minus pi by 3. Next is we have to calculate the value of tan inverse of minus 1 by square root 3, and let this value is equal to theta. So it means we are calculating the value of theta for which tan theta is minus 1 by square root of 3, and this theta should belong to open interval minus pi by 2 to pi by 2. From this we are saying this is equal to minus tan of pi by 6, that is equal to tan of minus pi by 6, and this minus pi by 6 it belongs to this interval. So what we get is the principal value of tan inverse of minus 1 by root 3 is minus pi by 6. The next question we have is we have to calculate the value of tan inverse of minus 1. We are saying suppose this value is equal to theta, and this theta should belong to the interval minus pi by 2 to pi by 2. So it means we are interested in the value of tan theta should be minus 1, that is equal to minus tan of minus pi by 4, that is equal to tan of minus pi by 4, and this value minus pi by 4 it lies in this interval for minus pi by 2 to pi by 2. So we are saying the principal value of tan inverse of minus 1 is minus pi by 4. Next question we have, it is cosecant inverse of minus 2. So let cosecant inverse of minus 2 that is equal to theta. Now the value of theta it should belong to the interval minus pi by 2 to pi by 2 minus the point 0, except for the point 0. So we are saying we are interested in the value that cosecant theta should be equal to minus 2, that is equal to minus of cosecant of pi by 6, that is equal to cosecant of minus pi by 6, and this minus pi by 6 it lies in this interval. So we are saying that the principal value we have with respect to cosecant inverse of minus 2 is minus pi by 6. Next we have to calculate the value corresponding to tan inverse of minus square root of 3. We are saying this is equal to theta. So we are interested in the value that tan theta should be equal to minus root 3, and we know that the value satisfying this theta it is minus pi by 3, and this value it lies in the interval minus pi by 2 to pi by 2. Next is find the principal value of the following. First is cos inverse of minus 1 by square root of 2. Suppose we are saying this value is equal to theta, then this theta should belong to the interval 0 to pi, because we know that the principal values or principal branch of cos theta is 0 to pi. So this thing implies us that cos theta should be equal to minus 1 by root 2, and this value is equal to minus cos of pi by 4. We are interested in those values of theta which lies between 0 and pi, and the answer we should obtain it is pi by 4. So we are saying this is cos of pi minus pi by 4, that is equal to, we are talking about the formula cos of pi minus theta, that is equal to minus of cos theta. So we have minus cos theta over here, so we are writing it is cos of pi minus theta, that is equal to cos of 3 pi by 4, and this value 3 pi by 4 it belongs to the interval 0 to pi. So we are saying the principal values of cos inverse of minus 1 by root 2 is 3 pi by 4. Next question we have is cos inverse of minus 1 by 2, and suppose this value is equal to theta. So this thing implies us that we are interested in those values of theta for which cos theta is equal to minus 1 by 2, that is equal to minus cos of pi by 3, that is equal to cos of pi minus pi by 3, that is equal to cos of 2 pi by 3, and this 2 pi by 3, this belongs to the second quadrant, that is belongs to the interval 0 to pi. So this is basically the principal value of cos inverse of minus 1 by 2. Next question we have, it is cot inverse of minus 1 by square root 3 we have to calculate, and suppose we are saying that this value is equal to theta, and this theta should belong to open interval 0 to pi. So we are interested in the value of theta for which cot of theta, that should be equal to minus 1 by root 3, that is equal to minus cot of pi by 3, this is equal to cot of pi minus pi by 3. The formula we are using, it is cot of pi minus theta, that is equal to minus cot of theta. So we are writing it is equal to cot of 2 pi by 3, and this 2 pi by 3, this belongs to the interval 0 to pi. So we are saying that the principal value of cot inverse of minus 1 by square root 3 is 2 pi by 3. Next we have to calculate the value of cot inverse of minus square root 3. So we are talking about, we want to calculate cot of theta, we want to calculate the value of theta for which cot of theta is minus square root 3. So we are saying it is minus cot of pi by 6, this is equal to cot of pi minus pi by 6, that is equal to cot of 5 pi by 6, and we know that this value 5 pi by 6, it belongs to the open interval 0 to pi. So the principal value of cot inverse of minus square root 3 is 5 pi by 6. Next we have is the function, it is secant inverse of a minus square root 2. Suppose this is equal to theta, where this theta belongs to the interval 0 to pi minus the point pi by 2, except for the point pi by 2. So we are interested in the value of secant theta, that should be equal to minus square root 2. So we are saying this is equal to minus secant of pi by 4, this is equal to secant of pi minus pi by 4, that is equal to secant of 3 pi by 4, and this value 3 pi by 4, it belongs to this interval over here, this value 3 pi by 4, it belongs to this interval. So we are saying the principal value of secant inverse of minus square root 2, it is 3 pi by 4. Next is we have to find the principal value for this range, for this the function that is given to us is secant inverse minus 1, we are saying suppose that is equal to theta. Now this theta over here, this belongs to the interval minus pi by 2 to pi by 2 minus, except for the point 0. So we are interested in the value of theta for which cosecant theta is equal to minus 1, this is equal to minus cosecant of pi by 2, this is equal to cosecant of minus pi by 2, and this value we are saying minus pi by 2, it belongs to this interval. So we are saying the principal value of cosecant inverse of minus 1 is minus pi by 2. Next we have is find the value of cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. So first we are saying that let cos inverse of 1 by 2, this is equal to theta 1, and sin inverse of 1 by 2, this is equal to theta 2. So what we get from this is that cos of theta 1 that is equal to 1 by 2 and sine of theta 2 that is equal to 1 by 2. Both these values are positive, so the values in the first quadrant are sufficient. So we get that the value of theta 1 it is pi by 3 and the value of theta 2 we have it is pi by 6. So the answer we obtain is pi by 3 plus 2 into pi by 6 that is equal to 2 pi by 3. So this is our final answer. Next is find the value of tan inverse of 1 cos inverse of minus 1 by 2. The first value we are talking about, the function we have it is tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. We know that the value of tan is 1 for the angle pi by 4 and it belongs to the interval 0 to pi. We are talking about this second cos inverse, it is 1 by 2. This value is for pi by 3. We require the answer to be negative. So we are saying it is pi minus pi by 3 that is equal to 2 pi by 3 and this value it belongs to the interval 0 to pi. Third case we are saying sine should be minus 1 by 2 and sine is 1 by 2 for the angle pi by 6. The value we require it is negative. So we are saying it is minus pi by 6 and this minus pi by 6 it belongs to the interval minus pi by 2 to pi by 2. So these are the values corresponding to these values. So the answer we obtain it is pi by 4 plus 2 pi by 3 plus minus of pi by 6. And on solving this the value we obtain it is 3 pi by 4. Next is find the value of tan inverse of square root 3 minus secant inverse of minus 2. We know that the value of tan is square root 3 when the angle is pi by 3, that is 60 degree angles, and the value of secant inverse is minus 2. This value will hold for, we are saying this value will happen at pi by 3. We require the answer to be negative. As we require the answer to be negative, so we are writing it is pi minus pi by 3 that is equal to 2 pi by 3. We are subtracting both these values. First of all we are checking whether these are principal values or not. So for this first value, this lies in the interval minus pi by 2 to pi by 2. So this is the principal value in this case. This second value 2 pi by 3, it lies in the interval 0 to pi minus pi by 2. So this value is also the principal value. So the answer we obtain it is pi by 3 minus 2 pi by 3 that is equal to minus pi by 3. So this is the answer we have obtained over here.